All right, so a way of organising and displaying data. So how do we often display data? With a graph or a table, okay? So you might get given a table which says like, so for different teams or something like that, and we might say something like, e.g., might have a table which says girls, boys, wins, losses, might be, and some numbers. Okay, that's a table. It's not a matrix, it's a table, okay? As a matrix, we would represent this information like this. Just if you can you just leave a little bit of space on the side here? So what things do you think are in a matrix? Pardon? Numbers? What else seems to be something which is a bit different on it? Brackets, okay? So all matrices have, or a matrix has square brackets. Always. If you forget the square brackets when you're asked to write a matrix, you're going to get it wrong because it's not a matrix without those brackets. Okay? It's just a way of being able to show data in a specific way so that we can then manipulate data and multiply, add it, subtract it, all those sort of things. Now, what we're going to talk about quite a lot is about rows and about columns. All right, so rows, which way do rows go? Crossway. Okay, so this would be row 1 and this would be row 2. Columns are going downwards, and you really need to know. Now, you wouldn't ever label these like that, like you would more likely write girls, boys, wins, losses if you were going to give them a label at all, but I'm just trying to show you row, column, okay? You need to know the difference between rows and columns, or this is just going to get really confusing for you, right? But what you need to think about is that the rows always come first. If you can try and always think that we think about the rows going first and then the columns, we go across and then up and down, most things will be pretty easy for you, okay? Everyone good to there? Okay, so we need to know some new words. So we know matrix, we know rows and columns. The next word we need to know is an element, okay? So one number in a matrix is called an element. We'll come back to elements in a second. Actually, we'll keep going. Okay, to name an element. Well, actually, no, we can't, sorry. Have to teach something else before I can do that. Let's try and jump ahead. All right, so we talk about a matrix by its size. Okay, how do you think we could talk about this matrix? If I was talking about the size of this matrix, any ideas on how I could? Yeah. The amount of rows and columns. So this is called a 2 by 2 matrix. Which one do you reckon's first? Which two's first and which two's second? Rows, then columns, okay? So we label a matrix with its dimensions, row number by column number. So, e.g., if we had this one, you can make up your own numbers. Doesn't really matter what numbers they are. We're not going to use this example for later. But you have to have that many numbers. If we had this matrix, what would its dimensions be? 3 by 4. 3 rows, 4 columns. Now, these numbers are actually going to be really important when we start particularly multiplying matrices together. You're going to need to know them. Everyone good with that, though? It makes sense? It's not very hard. It's just that there's just different words and things. All right, then we might have something like this. Yes? So our rows are going across. So the rows are across. So there's 3 rows. 1, 2, 3. There's 4 columns. 1, 2, 3, 4.
Oh, I see.
Yeah? All right, so then we might have this 8, 0, -2, 1. What would this one be? 4 by 1, okay? So go, how many times can we go across? 1, 2, 3, 4. How many times can we go up and down? 1. So it's 4 by 1. Now this has a particular name and you're going to need to know this name. I'm going to highlight all the words you specifically need to know. So this is called a column matrix. Because, why do you reckon that might be? Because it's just one column. I should go. This one? Anyone give me a number for the next one? 1 by 3. Anyone want to take a stab at the name for it? A row matrix, because it is only one row. Number? 3 by 3. Now, this one also has a name. And it's the same name as this one up here. Square, okay? Because they're the same, it's called a square matrix. Oh, sorry. And so anything which is a square is called a square matrix. So a 4 by 4, 5 by 5, 6 by 6. And you guys will have a lot of these this year, but also we use some matrices next year, and they're pretty much all square matrices as you go. So it's important that you sort of can see how they work. All right, is everyone okay with labelling them? So rows, then columns. You've also got a column matrix, a row matrix, a square matrix. Later on, so like next lesson, we'll look at some other ones as well. There's like a 0 one, an identity one, a few different ones as we go. Okay, so we can label it with its dimensions, but actually more often than not, we actually give it a label, okay? And so we label a matrix with a capital letter. It's a bit like sort of just saying x equals 6, but instead of saying x equals 6, x equals this table of data, this matrix. It's almost always, it is always a capital letter because we use the lowercase for something else. So for example, and we'll use this example for quite a bit, A equals 3, -4, 0, 2, 5, 1. So you'd get told that. You'd get told that this matrix is the matrix we're using, and what's its label? A. Okay, so in the question, you'd be given those labels. So we label them with a capital letter. Now, this next bit is something which everyone always seems to forget. It seems to be that little thing we talk about in the first lesson, and people forget it, and then it comes up in a test, and everyone goes, I didn't know what that meant. Okay, so I really need people to make sure they take this in. So see how the matrix is called a capital letter? If we then want to label an element within it, what's an element again? One of the numbers. We have to use the lowercase of that letter. And then we have to say which row and which column it's in. So I'll give you an example and then I'll write down what I mean, okay? So if I wanted to find if I wanted to look at, let's say, the -4 there, what I'd do is I'd write a lowercase a, and that's telling me it's an element in matrix A, and then I need to say which row and which column. We always do which ones first? Rows. So it's row 2, column 1. That's how, so we'd look at that and we'd go, that is -4. What would A 3, 2 be? 1. Now notice that these letters are little. You can't write that is not the same as, and don't write this, that is not the same as going like that. Okay? They're little letters below, they're like subscript. Can everybody see that? Okay, so let's just write it in words because that might not make sense later on when you go back to your notes. So to label an element in a matrix, we use the lowercase letter and does everyone understand subscript? What I mean by subscript? So small. Subscript numbers to show the row and column. So e.g., if we go A, 1, 1 or 1, 3, the A means matrix A. The 1 means row 1. Oh, hang on. Can't do 3, can we? Can do 2. There weren't 3 columns. A means row 1. 2 means column 2. And so therefore A 1, 2 equals row 1, column 2, 2. Everyone good to there? Good. All right, so once we've got this information in matrix, we can then, what I said was like, we can then manipulate the data. So we can then like multiply it, we can add them and subtract them, and like there's big ways of being able to find out lots of information from matrices when we know how to do certain procedures, okay? So what we're going to start with is just multiplying a matrix by a whole number, okay? So we're going to start looking at some different things. Then we'll get the skills down, and then we'll go to the applications, if that's okay with everybody. So can you write multiplying a matrix by a number? We're going to start with the easy stuff. All right, so e.g. B equals 3, 5, negative 2, 4. Okay, this is the question. And then it might then say, so that's sort of our action, and then we'll use another one as well. I might say C equals 4, 1, negative 3, 0. Okay, so that often in a matrix question, you'll get given a whole heap of different matrices, and then you'll get asked to do things with them. So your question might then say, evaluate (3b). So what does that mean? So it means 3 times matrix B. So if you have a number at the start, all we have to do is actually multiply each thing in the matrix by that number. It still stays as a matrix as an answer. So what that means is we multiply every element in the matrix by the number. So 3b equals, we still end up with the same size matrix. 3 times 3, 9. 3 times 5, 3 times negative 2, and 3 times 4 is 12. The matrix solution will still be the same size. We'll still have the same dimensions. Make sense? Not very hard? Not at all. Can I give you one example to try? So can you try with the same question? Negative to evaluate. It might say find, it might say solve. Well, I probably won't say solve. Determine, might say determine. Negative to C.